So we'll go through the material. I've got some PowerPoint presentation, and then we'll see how it goes. And if you have any question, by all means, just post it, and I'll try my best to answer them. I can tell you that the um, UHPC or ultra high performance concrete has found a great uh, home in the bridge engineering community, but for some reason, the building community, for most part, really are not very familiar with the UHPC. But recently, I mean, some changes are being made. I mean, this is not to say that, for example, at the ACI level, there is no activity. There is activity, but if you talk to building contractors and the professionals, really, the applications of the UHPC has been, I mean, extremely limited or non-existent. And uh, but that is not the same story in the case of the bridges. In the case of the bridge, really, um, the UHPC the UHPC as a material really was developed early in the 80s and so on, a little bit earlier than that actually in Europe, and then the commercial version of it became available. But right now, actually, there is a non-proprietary version of it, or open source, I recall, is available. So I will elaborate on that. We have developed many applications of the UHPC. Um, they are developed for bridge application, but they have equal application in the case of the building as we go through. So with that, let me just start. So first of all, who we are. This is a little bit older slide, actually. The Accelerated Bridge Construction University Transportation Center was first funded in 2013. These are a very extremely competitive process, like 220, 240 proposal consortium, I say, because each proposal consists of several universities. They get together and then they prepare a proposal and submit it. In 2013, we were fortunate at Florida International University to lead one and get funded from 2013 to 2016. There was another competition in 2016. We were again fortunate to get selected um, from 2016 to 2023. In fact, with 1 year extension, it's going to go to 2024. In 2022, there was also another competition. And again, we've been fortunate for 3 times in a row to get funded by U.S. Department of Transportation. And that one is going to actually is just getting started. So there's an overlap between the 2016 grants and the 2022 grants. But 2022 grants is going to continue on to 2039. So we get from the US DOT, we get about $2 million grant every year. But in the new University Transportation Center, our partner universities are everybody that you see here: University of Washington, University of Oklahoma, University of Nevada, Reno, but also we have added FAMU in Florida, University of Georgia, and Texas C&M. So we developed quite a bit of a technology, and so the bridge industry knows who we are. And we have a website also that is abc-utc.fiu.edu. I'll try to show our website later on, which has tons of information. So just right now, tentative, really, the presentation outline. I do have a tendency, sometimes I go a little bit on, in order to elaborate on a topic, I bring some additional discussion. So, but nevertheless, I mean, this is what hopefully we'll be able to cover. What is a UHPC, current practices and non-proprietary mix, We'll discuss the durability of the UHPC. In the bridge application, it's the durability really that's the main reason we are using. It is a strong, I mean, the compressive strength can go from 18,000 psi all the way to 28,000 psi, even higher than that. But the durability is it's very durable. The rapid chloride permeability numbers with this material is in order of the 20 to 40 coulomb compared to 2,000 to 4,000 coulomb that you will see in a case of a conventional concrete. Freeze top, after 360 cycles, freeze top, you still have the same specimen.